we have different questions from your end and different in forum questions, in Google Sheet questions, and some few questions are left out in the last session also. So we'll cover as much as possible. I believe we consider in these 55 minutes or so, we'll be able to finish all. So let us start the session. So we have questions asked in the Google Sheet, which is the previous one. So we'll go by one. So the first question is, you can say that power system protection in specific industry like NTPC, Power Grid, West Bengal State Electricity Distribution System Limited, NHPC, and so. So perhaps I wish you can say that is asking on the job perspective and so. Yes, any power you can say that industry having network or any you can say that electric I'm say that system elements, maybe generating units, maybe transformer, maybe motors or so, you essentially require protection. So what you say here, you can say that the thermal power station, the power grid having networks, this is having generating units and the associated substations. They may be having few transmission lines and so also, and including transformer. Each of the elements need protection. So we need essentially a protection team, you can say that for that one. And that too can say this is also network operators, and so also this hydro, so that plant you can say that having by the NHPC, and any you can say that industrial utility in electric, you can say that city grid or generating or distribution system or so, you can say that they must be having protection team to manage the relay operation and so. And in day-to-day business also, those who are in charges of the substations, lines, and transformer, generator, and all these things, they essentially need to consider that knowledge on protection. The second question is on kindly share recent research trends in transmission line protection. Excellent questions on timely also. So you can say that today we have renewable integrations, which we have covered in the subsequent modules also. So with the introduction of these renewable resources, which are mainly you can say that fed through the converter systems like photovoltaic system being DC converted to AC through an inverter and then being fed to the grid through an inverter circuit. So this you can say that the corresponding current voltages are being modulated much differently than the synchronous machine based systems which you have in general, as of now in general. So therefore the fault characteristics in terms of the voltage and current pattern provided by the corresponding such you can say that resources, such energy resources or generating units are much different, and therefore you can say that the transmission line protection finds problem conventional law. This is what I'm saying that industry has started observing, and so also you can say that we'll find you can say that concurrent research topics and solutions for therein. There is one perspective. The second thing is that because the transmission systems or the grid you can say that are more vulnerable, so and if the fault persists for a much longer period, then stability becomes an issue. Now in that sense, the sooner the fault is being cleared, the better it is. Point 2, with renewables, the corresponding system inertia decreases, and therefore you can say that stability is further you can say that is questionable in terms of delayed you can say that protection decision and so. So therefore, for the speed of operation of the protection system, one of the aspects is that the total fault clearing time depends upon the relay decision time plus the circuit record time. So here what we have covered in this one is on the relay perspective. So can we have a faster relay decision? That's the question. And that to particularly transmission system and high voltage systems in particular, because we are more concerned about the stability in case of extra high voltage system or high voltage system. Then so, yes, there are solutions which are going on the time domain perspective. One important solutions we have already provided in our, you can say that one of the modules also on traveling wave based protections, where you can do the protections within millisecond also, within millisecond. And because the traveling wave goes very close to that, you can say that light speed of light, and that's the reason you can say that you can accomplish within 1 millisecond also such protection schemes. The other thing is that as I told, you can say that from the very beginning, 90% of the, you can say that the relays available are the sequence component based or the phasor based approach. So therefore, now the question is that once you start computing the phasor, it takes a cycle or so to settle down the correct estimation of the phasors. That delays the process. So therefore, now you can say that the solution which is emerging is based on time domain approach without going to the phasor based approach. And that is what the other part of the time domain, besides traveling wave, on time domain, can you do the protection and so superimpose component and so. So you'll see literature, you can say that it is available, so many techniques currently on line protection, transmission line protection based on time domain approach, including traveling wave based approach and so. So those are, you can say that the hot topics in transmission line protections. If you are interested, you can go into like that also. Please explain what is pilot wire. So these are communication wire. We can see a book, any book. The term pilot refers to a communication channel. It is a communication channel between two or more ends of a transmission line to provide instantaneous clearing of fault, or you can say that also you can say that in the system. So this we are referring to a communication channel, you can say that for this perspective of protection application and so. So that you can say that the wire, corresponding wire can be fiber optic, can be the normal copper based wire and so, as you know, for different system, different communication application and so. The fourth question is on, in assignment, numerical problems require calculators, fine, and more time, true, and then how could be solved in the examinations, where whether both scientific calculator will be available or which are having more time or so and all these things. So this is a good question. For your information, see, first and foremost purpose of a course is to learn, gain of knowledge. Examination is another part. So many of you are appearing examination also. On that perspective, you have put a question. So assignment and all these things, that part you can say is with the knowledge game. Yes, that has also, you can say, implications to the examination also. In examination, you can say that this will be conducted by TCS and all this, TCS also. And you know the GATE examinations, the examination, and so the type of calculator provided in that platform, the PC or so, that will be available as we know. And therefore, in the examination, considering all the resources what will be available, the questions will be set. So don't you can say that bother about that the long calculation, possible, not possible. All things are taken into account. And this is this course is not, you can say that exceptional course also. This is similar to a course for other things also. And the examination will be not a special examination. It will be an examination as usual for taken care by the NPTEL perspective and so. Going to the fifth question, simple. What is meant by overreach? So this is already covered in the distance relay. Perhaps by this time the questioner has already understood this one, but still then you can we'll go into this repetition because it is being asked and so. So we have a transmission system also where the distance relay is having here, and then let us say we are talking about a zone 1 setting. Okay? This is zone 1 setting. Then 50 ohm, 70 ohm, whatever setting is there and so. So with respect to the setting, this is called reach point. This is called reach point. So on this reach point, left or right. So we are talking about underreach or overreach perspective and so. So there are two terms, underreach and overreach. So we say, can say that the distance relay is set to underreach when the impedance seen by it is greater than the actual impedance. Seen means computed by this actual impedance where the fault has occurred. That is the actual one. So that will be our reference one. So now in terms of that, if the corresponding thing is there, so whatever impedance is set, let us say a fault happens to be at the zone. Now, however, you can say that your apparent impedance sees the fault less. You see here, you can say that the apparent is greater. So this is greater for the under these things. So the apparent impedance seen by this is greater than this perspective and all these things. So what you need, you can say that is to say that if the corresponding apparent impedance is seen by is greater, then what will happen here? No, So there the relay will not operate. So it means that when the corresponding fault happens to be here, then it gets the corresponding 50 ohm or 80 ohm set value and perspective and so. So at the reach point, you can say that whatever apparent impedance will be seen for a fault at the reach point, whatever apparent impedance seen, and then you can say that the corresponding Z set and the Z set that gives you can say the percentage of underreach, you can say that by this relay in case of underreach phenomenon. And so once again, this is the reach. So the relay, because the apparent impedance seen by the relay becomes more, so therefore you can say that the zone 1 setting reduces, and that is what the underreach. And similarly, you can say that you can understand the overreach. You can say that aspect overreach impedance means the impedance seen by is less. So therefore, at this point it will see the set value. You can say that. So therefore, this first portion will be left out and all these things. So relay reach becomes less because the apparent impedance seen by the relay is in this case you can say that it's less. So that is what the underreach and overreach aspects issues with the relay perspective. I'll go to few questions which are left out in the live session 1. So first questions, what are the fault analysis methods for DC system and so. Now let us come to AC system. In AC system, we analyze the fault in terms of the sequence component based approach to avoid the Fortescue's approach, and so that is why proposed by that long since. The reason behind that, the mutual perspective is lost, and so all the advantages we have enumerated there. Let us think about the Poetic sequence diagram. In the Poetic sequence diagram, how do you analyze? Once the Poetic sequence diagram is there, let us say 3-phase fault or so, you analyze by the corresponding network analysis for AC system what we have learned. So for the DC system, when a fault happens to be there, so we draw the fault circuit, and the fault circuit can be analyzed by any network theorem analysis perspective, and so which you know well. So the fault analysis, once you draw the corresponding loop for the fault, you can analyze by the different methods available to for your knowledge on the DC system circuit analysis and so. The second question is on what is the CT class required for directional overcurrent protection? So this is protection. So CT class is P class, protection class perspective. But as you have seen, we have addressed here on IEEE or a ANSI standard and so. So 10C 400 and all these things that is already well addressed that what is that the CT selection and so. What level of accuracy required will dictate that whether you require 10C 400, 10C 800 and so. And they depend upon the how much the economic aspect, how much you can pay for that particular thing. More accurate, more you can say that will be costlier the CT perspective and so. Third question is on how open conductor fault are detected. There is a question also last time that about the open conductor analysis, how can be carried out and all these things that is already discussed. Now this question is on how open conductor fault are being detected by the relays and so. So whenever you have open conductor, you see here, then no current will be the open conductor. These conductors are maintained. So this means that the corresponding this side, suppose we have a source from this side or so. So then this is a 3-phase system. So then we say that this has no current, zero. This current becomes zero. Let us say IA and IB. You can say that current will be there and IC current will be there. So that means that there will be a lot of unbalance. It means that there will be a lot of I2. So this I2 by I1 ratio is clear indicative of the unbalanced situation. But we have already understood that in case of a line to ground fault, phase to ground fault or double phase to ground fault, the negative sequence current becomes more. Unbalanced fault, negative sequence current becomes more. So for fault also, negative sequence current will be more, and this I2 by I1 ratio will be higher. True. So therefore, for this reason, what is being done that yes, you provide substantial time so that the protection system, normal protection system for sound fault, what we have already studied all the things for the sound fault, that clears the corresponding fault. Let us say we talk about 2 seconds, 5 seconds, that kind of longer duration, because open fault is not dangerous for any damage or so. Only it may be to the load side induction motor or so might having single phasing issue and so. So this we can say that you allow sufficient time till all these on faults are being cleared, if it is so, and if it is an unbalanced, if it is an open fault, open conductor situations, then by this you can see the ratio, you can do this job and all these things. There are more advanced versions and adaptive things and so on, so though to make it faster, and so you can see any literature to go for that. But in general, this I2 upon IA is a good index for classifying open conductor systems, but with a delayed time. So discussion forum, we have few questions, so we are going into that. Now, one is on the transformer differential relay. So this is on vector compensation perspective, and the question asked to consider is on the negative sequence based relay. What will be the corresponding vector compensation? Just to have a refresh on what is that vector compensation, and so we know that the high voltage winding will degenerate at W1 and low voltage winding degenerate W2, and the high voltage pi to capital ABC and low voltage will degenerate small ABC as per our convention. That is what we have followed in our lectures. Now we have CT1 group and we have CT2 group, and from these cities both sides are star connected in a numerical platform, and then we have a normalization state with both sides. Then we have zero sequence eliminations both sides, whether star, delta, immaterial. In delta side there is no zero sequence current as such, we know. And then we have a vector adaptation at the low voltage side. Vector group adaptation at the low voltage side to make the phase matching, matching for the required things. We know the star delta has some phase difference between this side current, line side current, and this side line current. So therefore, that has to be done, and that is done by the vector adaptation. Then only we talk about the differential current, where we have the corresponding percentage by differential characteristics, I operating versus ID straining, and then we have a setting of M1, M2, and so and so. So this is trip region, and this is block region, and so in terms of that. This is what the different steps being followed for a differential protection, and so. So what we say that in the vector adaptation, how that is being carried out, that we like to evaluate here. So that is in step 3 perspective and all these things. So what I already enumerated in that lecture also, that we have high voltage winding is the reference, and low voltage winding follows the high voltage winding. And we have a K factor, that is the vector group mentioned, that YD1, YD11, and so whatever is there, that 1, 1, 1, 2, so that 5, 6, whatever that number happens to be there, that we call as K, and multiply with 30, that gives the corresponding theta angle for that perspective. So the vector adaptation is applied to the low voltage winding, as already mentioned, and the corresponding angle is being computed in terms of K30 or so. So what is here is that we see here for the positive sequence perspective, you see here the positive position perspective, we take the reference at the high voltage side always, and the corresponding low voltage side lags by an corresponding theta, but theta is nothing but your K into 30 degree, and K is your vector group number 1, 11, 5, 6 or so. So this leads to this kind of thing, and this is what we talk about in terms of IA, IB, IC, and all these things. We can see from this phasor diagram also. But what happens that when it goes to the negative sequence current, the corresponding, because of the phase sequence is reversal, the negative sequence in that situation, the negative sequence current will be the other way. That the corresponding negative sequence current, the negative sequence current from the winding 1 and winding 2, the winding 2 leads by an angle of theta in terms of that. So that's the corresponding problem to do the issue of that. So here this is lags, here it is leads, and the division is because of the phase sequence reversal from the positive to negative side perspective, and so. So this is the essence of the difference between positive and negative sequence, the angle perspective. Once you understand that, you can see that we'll proceed in terms of that. Now we know that we have already eliminated the zero sequence component from both the sides. So zero sequence is no more present. You can see that in the vector group adaptation side, only positive and negative sequence components are available. So we have only positive sequence and negative sequence, you can say that component available. So that we have to adjust in terms of that. So this about I positive and I negative perspective, and so, and how to adjust that we like to see. So we saw that to adjust the angle of the low voltage to this, So in the positive sequence, we multiply with AJ theta, and to adjust the considered angle, coming back to the high voltage as a reference to the high voltage side, because our adjustment will be on the low voltage side. This is on the low voltage side. The red one is low voltage side. So therefore, the negative sequence must be multiplied with e to the power minus j theta. Agree? That is what the phase adjustment we do so that there be no phase angle difference between primary side line current and secondary side line current. And now, in the comparison when we are going, we are only considering positive sequence and negative sequence component. Zero sequence is already eliminated because delta side transformer line current does not have zero sequence, whereas star grounded side it has zero sequence. So that extra current has to be subtracted, and that is what we have eliminated the zero sequence current perspective. So in this one, finally, when you derive consider in terms of e to the power j theta, e to the power minus theta, so there were derivation if you see, there is a C term and all these things that is well defined in terms of that. And finally, you can say that to this phase currents low voltage IA, B, C, if you multiply this encircled part, then that becomes the corresponding comparison with the phase current parts of the high voltage side, which are having after the zero sequence elimination. The Z stands for the zero sequence after the zero sequence elimination. The C can say that matrix here is defined here well. So now if we proceed to this, then with alpha being 120 degree and all these things, we get the matrix you consider in terms of cos k 30, cos k plus 430, and cos k minus 30, and like that. That we understand. Okay? And then we proceed in terms of the vector orientation, and we talk about transform protection of this kind of things. So here for k equals to 5, k equals to 1, you substitute the value and you get the corresponding matrix to get the corresponding the voltage for this perspective, which will be compared. So this part can be obtained from these relations after multiplying this matrix and this 2 by 3 factor and so. So this is well known. You can say that we have solved problems and all these things in terms of that. Now comes that yes, scaling and phase shifting competition and negative sequence filter. So what you do with that in this case, that if already you can say that IA, IB, IC, those are the corresponding multiplications we did like this here. If you see this, all the perspective of A, B, C and multiplying this one, then here also if you do that, then and after doing that, if we extend the corresponding negative sequence current both the sides, that we are talking about high voltage, low voltage. In the low, whichever side is the low voltage side, we talk about that. And so that your adaptive, what you call the vector adaptation, here in the low voltage side. Then essentially there is no zero sequence current. So zero sequence current into that part will be zero. So you don't have any problem. So you use that, you can say that same one, what we say here, this you can say that part, here also, and then absolutely negative sequence, then you compute the negative sequence current, filter out the positive sequence current, capture the only negative sequence current, then you can compare and do the business as usual. Absolutely no problem. So that was the question asked in terms of that. However, if you like to have only from the very beginning, you like to extract only negative sequence current from the phase A, phase B, phase C by multiplying these things, then we have a simple derivation here for your information. So these are only negative sequence current. So like we can say that we are not no more using, you can say that the other component of current. So we only multiply this factor to the negative sequence current of the low voltage side. Agree? This is high voltage side. So that factor comes into picture. And then if you go for, you can say that then this comes out to be a matrix like this, which will be multiplying to these phase A, phase B and phase C components on the low voltage side, and which will be compared with the high voltage side currents. So this factor comes here only when you consider the negative sequence current, no more positive sequence current available in the circuits. And if you go for analysis of this one, then you get a factor, you can say that the corresponding matrix to be multiplied comes out to be this, And here, in earlier case, we are getting cos term because of j theta plus term and j theta minus term were there. So we are getting a cos term all real value. Now these are, you can see that a complex term comes out to where we have a e to the power minus j theta multiplications to all these elements, 9 elements in this case perspective. And that the different, you can see that finally the equation comes out to be this. So point is that the corresponding matrix which we are handling there, that cos k cos 30 and k plus 430, k minus 430 and so. So that will be when we are considering both positive and negative. And when we are only considering negative sequence current, then we have to multiply with this factor. Perhaps I believe you understood this one. But mind it that if we are using in a normal relay and with both positive and negative, we are using the vector adaptations, and then we are extracting the negative sequence current, absolutely no problem. Now, the next question is on the area protection of transformer. So the question was, in the lecture, it is shown that during an internal or external fault, the fault current enters the transformer neutral, and the fault is also voltage fault. The fault point and the transformer neutral are at the same potential. How can the fault current enter the transformer neutral? Can you please explain on the path of the fault current, please? The question asks, you can say that maybe by an engineer or so. So the point is that if there will be a three-phase fault, then balance fault, then what happens in an area protection and so. Mind you, there are three-phase balance fault means there is no point of the ground, so ground current is not there, and therefore you can say that it will not go to the neutral part of current and so. Expect it. And however, nothing is perfect balance and so. If there will be some imperfection and unbalanced three-phase fault and ground is also involved, then there will be ground current. That is what we say. We'll see that. Now the point here is that if you have that situation, no ground current, then REF will not operate. Perfect. But that does not mean that we have a differential protection which takes care of the phase current. So that is already there. Agree? So this REF is in addition to the differential protections what we have already enumerated, and REF is more sensitive when the ground is involved and when there is a ground current. If there is no ground current, there is no role of REF. And that is as straightforward this one. Okay, to just revisit that, you can see that to clarify to all of you, can say in terms of that. So we know in our presentation for the transformer protections on the earthfall protection, sensitive earthfall protection and so. So what is being done here? See here. So this is an internal fault. This is our transformer. For this internal fault, the current from this side, because this side is source, the current from this side goes like this, and current from this side will go like this. Agree? Because there will be source from this side also, interconnected system and so. So what we see here is these are the two paths. Now let us look for the external fault. Again, from this source, the current will flow this side. So no change in current direction in the neutral path. Now the current here goes to this. So see here, this path and this path, there is current reversal. Agree? So therefore, this is an application of the directional leading perspective. If we consider the neutral current as the reference, note, if we consider the neutral current in the reference, in one case, if we align the corresponding CT such that here, if this corresponding current is in phase with this, theoretically, in this case, this will be out of phase with respect to neutral. And that is what is being done in this perspective. So the angle between the reference neutral current and the corresponding zero sequence current computed in this perspective will be in terms of they will be almost in phase or something, some angle deviation and so will be there. So it will be in this region, you can say that that is a trip region, and then out of phase region, you can say that is a no trip or block region because that is external fault. And that's the region you can say that we say this angle based, and this is very sensitive in terms of that perspective and so. That leads to a situation of this thing, you can say that, which we like to explain. And if it is a three-phase balance fault, no neutral current will flow, and you don't have any answer to that perspective, and so then phase relays will operate in terms of that. But phase relays are there; they do take care. But the sensitivity of the residential, the restricted earthfall relay is much higher. That we have already enumerated in terms of this. Another question on the forum was the current reversal in the permissive overage transfer trip scheme in the distance relay application. And so the question was, please explain what type of supervisory logic, what kind of supervisory logic is required to maintain POTT scheme not to operate in case of current reversal. The issue is current reversal, agree? And what kind of supervisory will be there and so. So literature does not suggest, but still then we can intuitively say something, consider. Let me elaborate on the issue. So issue is here, there is a parallel line. Let us say the issue is here, the parallel line, what we have narrated in our lecture. And let us say then a fault happens to be in the second line at F. The current path of will be this, some current will flow from this side also. Now let us look this current. So what will happen here? Because this is internal, this 4 will trip. So the 4 breaker is open now. Once the 4 breaker is open, because this is an intercurrent resistance, current will flow from this side to this, traverses this path, and then you can say that reaches to this. Okay. Now what you observe here, that earlier the current was in the same situation, earlier the current was flowing like this, and there is a current reversal from this one. That is what the current reversal condition. So here you can see that for this also, it was these directions, now this becomes this direction. Now what is POTT? POTT talks about, you can say, overage perspective, zone 2 or so. So therefore what will happen here, because this fault may be seen in the zone 2. This fault may be seen in zone 2. So earlier this was able to see this in zone 2 because of this. So therefore maybe, and then you can say that in that case, so this might have sent a trip signal to this one. Agree? This might have sent a trip signal to this one. This end you can say that was not able to see a trip signal, so no operation. And this side also sending no trip operation, so no operation. True. Now in this situation, after the opening of this one, this is also a trip signal T, and this is older. You can say that the old, you can say that signal of this is trip operation. If that old signal of T operation will be used, then T and T means you can say that it is opening at both the ends. True. But at this condition, after the corresponding reversal of the current, here you notice that you can say that this is a reversal of current. This is not in the forward direction, this is in reverse direction. So therefore, if you are continuously monitoring at both the ends, for this is forward fault at these situations, but for this is a reverse fault. So therefore, if this reversal is noticed here, which should be and which the relay does usually, and that continuous monitoring of the ZPTT, so that signal is desperate to this, that this is a reverse fault. So this will not operate, neither this will also operate. And that is what we have seen in our response also we have given, that that the local overage element information should be updated continuously. That is what the relay does also. Relay monitors the things continuously also. And the end operation by this way will provide a no trip decision. That is what the POTT is there, that end operation, it is permissive. So end operation, so the relay will not malfunction in terms of that one. However, if the once a decision is there and that information is stored and is being used throughout, then we'll be in trouble. Otherwise, it will not be a problem. So this goes for, you can say that our different questions and so. So we have few more questions online available from the YouTube. Let me read some of them, whatever possible. We have few minutes time also. Is circuit breaker operation permissible during stable, unstable power swing? Is circuit breaker operation permissible during stable, unstable power swing? Note, power swing is not a fault. Agree? Power swing is not a fault. So the relay, job of the relay is already clearly defined. It is a protection arrangement, protection schemes which protects the system during a fault. True. Or any dangerous situation happens to be there in the system, which may lead to damage of the element or system. During power swing, we don't expect there is a possible damage. So the relay should not trip. Relay should have a block. However, in impedance relay, what we have noticed is that the apparent impedance enters into some of the zones, typically zone 3 and so. So there is a chance of malfunction, and that's the reason we talk about power swing blocking. During power swing, the relay has to be blocked. This power swing blocking is there with all the distance relay protecting lines. True. Now, in case of unstable power swing, that may lead to damage, and so, and the that may lead to unstable means what? Some of the alternators will go out of control. So that is not good. So therefore, at strategic locations, we have narrated this in our lecture also, at strategic locations, out of step tripping arrangement there, where in an area, if you trip that area will still be able to sustain by managing its load and generation balance. Otherwise again it will be more vulnerable, it will degrade and it will collapse everything. So therefore, the industry, the utility, the power grid, they have at strategic locations to address this unstable power signal out of step tripping options at strategic locations where you can manage. Like if we think about this, the 2012 blackouts, both the days, the western region survived because they got isolated, and that western region managed of its own by managing its own load and generation balance. CSC in Kolkata, they have considered their own isolation arrangement from the main grid, from their connections to the India grid. And in both the days, you can see that in many times also they get isolated and they manage their load and generation and they sustain. That is what is being done. The recent Mumbai blackout and all these things, that is what is being concerned now, that how the corresponding isolations at the tile and critical lines will be there, so that this is Mumbai can sustain even during such period and so and so. Second question, how to select best load flow case for protection related simulation, particular for system with large number of buses. Base load flow case for protection related simulations, particular for system with large number of buses. So this, you are talking about the load flow means current given. So current is the issue. So you talk about see who creates problem, how to which this, see, load is not a problem or protection, but load is decides. Let us say think about simple lower current thing. Load, full load current, rated current, maximum load current in that line, in that system, in that element decides the setting of the protection arrangement, over current relay setting. So we know that it must be higher than the maximum load expected in that element, in that line. So therefore, when you set, you see that perspective and so what is the corresponding maximum load which lead to the maximum current through that line or element is your concern. So from protection perspective, what matters to you, accordingly the corresponding load should be there. No load, this and that does not, that will influence the perspective and so. In addition to that, you know that the default current, that is load current, influences the performance of the distance relay and so and so. So if you like to study on all the details and all these things, so then the corresponding loading conditions will be the worst scenario or so that the relays should not be vulnerable during that kind of situations. Question 3. How to model the renewable energy sources for power system protection studies? How to model? We have a special module on that. Please look into that module on renewable energy based protection and so. These are converter based protections. The question is that perhaps once you go through this one, it will be clear. As already mentioned in our earlier question also, renewable energy, particularly PV systems, wind energy and so, these days they are being connected to the systems through converters. These converters, they do function differently. Like one situation I will say that the converters, they have current limitation. So therefore, current limiting functions must be there in the converter control to for their own, avoiding their own possible damage. So that limits the current depending on the rating of the converter elements. So that means that the current is being limited. So we have limited current. Unlike in case of synchronous machine, sub-transient period, transient period, and so that will not now happen here. So the current may be at par to the maximum load current or the rated current of the system and so. The current not being high, over current relay fails. First question. Now V by I, that the simple V by I function, let us say not I, rather V by I dash, I modulated, suppose line to ground fault also, VA upon IA plus K naught I naught or so. So that IA becomes reduced, if the IA becomes reduced one, not the normal IA which expect instead in case of a distance issue with fault in the line or so. The IA does not increase significantly as expected. So therefore, what will happen? That the impedance seen by the will be much higher. Furthermore, the corresponding control is being current. If we see our discussions there, the current is being still tried to maintain to be balanced. That means that the phase angle also gets modulated much differently than that of the synchronous machine situation. So therefore, both phase and angle being modulated differently. So we'll see directional relay problem, distance relay problem, overcurrent relay problem, and all the perspective. The modeling will essentially require the converter model to be a detailed model with all the control embedded there. Particularly India grid 33 kV onwards, we have there our grid code. So fall right through and all these things, how the corresponding reactive power will be injected to the systems to this converter control during that time, that you have to follow, and you have to incorporate the corresponding control in the embedded converters. So the model should include those things, and these are possible in the PS card model and other, you can say that electromagnetic transient packages, which you might be using for the protection application. These are different perspective and all these things in terms of that. The next question is, can numerical quad relay operate on what operator?
Operate on comparator principle.
Okay. Can numerical quadrilateral relay operate on comparator principle without calculating apparent impedance as in more relay? Yes, that is also possible. So we have to do that in terms of that. We have to formulate in terms of that. It's possible. But numerical relay has enormous scope. You can say that it is your logic. You can also decide a logic. Like I can say that below the reach line, below the right of the impedance line, left of the resistance line, and so and so. So whether the corresponding point is inside the quadrilateral characteristic, that matters to us in terms of that perspective. Yes, it is possible, you can say that in terms of that. Shall we call a relay as ID? No, not all relays are there. Intelligent electronic device has certain specification and all these things. Just have a look what is that, which one you can call is intelligent device, which can communicate, which can do, and there are standards related to that. So not all relays are ID, but distance relay and all these things. Most of the relays, numerical relays, we can call them as ID and all these things today. Okay. Any other questions? So is there any operational grid code in India for integration of solar systems into transmission system? Yes, we have grid code now, the 33 kV and onwards. That grid code has to be followed, and that is what we follow right through in perspective. Please see our the renewable integrations modules. We'll find that the Indian grid code how we have managed with that also. So absolutely, it will be clear in that one, and we have provided that. In case you need material and all these things, you can write through the forum. We'll provide that material, relevant material on that also. We have also mentioned about other grid codes also, European grid code different, and then North America grid code different in some perspective, and so our grid code is very similar to European grid code perspective, and so in that aspect. Note that it is now up to 33 kV, but when you go to the lower voltage level and all these things, we don't have that the corresponding renewable energy resources, they get disconnected from the systems because distribution system cannot sustain. It is not a macro grid. If it is a macro grid, and so you can say that it can still be connected in the system, and so we don't have grid code for that perspective, and so. Is wide area protection implemented in India? No, no. Wide area protection is a ambitious target, and we'll have system integrated protection and so. But what I like to say that we have I cannot tell the exact, not able to tell the exact figure of how many PMUs and so. So we have hundreds of PMUs connected now, and we have all, you can see that PMUs are connected to the different PDCs, and these PDCs are again the area PDCs are again connected to the national level PDC at Delhi, Kosoko. So if you like to have a look, you can see that how the corresponding wide area measurement systems is useful in monitoring, and so. So that is the final target, how that can be done. But mind that this, when you say wide area protections, we can do it area wise. You can do few subsystem, and so you can do particular network system, subsystem, and so in terms of that. And you can use different applications like system protection scheme, backup protection scheme, supplementary protection scheme, and so. In our module on the PMO technology, we have given some examples on that perspective, and so. And I believe in future, India will be also able to do some of the wide area-based protection system also. Wide area monitoring systems, oscillation detections, and all these things are already established in the India grid based on synchrophasor measurements or the wide area measurement systems. So we have another question. What is the expected value of X by R during power swing as circuit breaker operation depends on X by R? Due to higher value of X by R during fault, generally sub-cycle tripping is avoided in India grid. What is the expected value of X by R during power swing as circuit breaker operations depends upon X by R? Due to higher value of X by R during fault, generally sub-cycle tripping is avoided in India grid. Okay, sub-cycle tripping is avoided. What is the expected value of X by R during power swing? As circuit breaker operation depends upon this. So whatever it may be during power swing, there is no point of tripping. There is no point of tripping. So I believe we can the circuit breaker tripping is not the issue. If you are talking about out of step tripping and all this thing, that is one issue, true. But normally the distance relays which we have, because parsing blocking is there, and this is during normal swing, and so the issue of the fault clearance will not be there. However, if it happens to be a misoperation, maloperation, and all these things during that kind of thing, which occasionally happens due to the improper setting or improper power swing blocking function, and so, then it is an issue in terms of that. So the X by ratio in that sense on the swing perspective and all these things will be a modulating figure, because this is apparent impedance in by this relay, and we know the trajectory during swing. Sometimes it enters, sometimes in there, and then it depends on the swing behavior, and so it will be a system specific, disturbance related at different points, and all these things it will be different. And you know the trajectory, that apparent trajectory depends upon the system condition, and so therefore that will be also X bar ratio will be also varying in nature as seen by the relay. So this finishes our questions. Nice questions. It enriches our knowledge also. If we have any further questions, please, it will be enriching all of us. Please pass on the corresponding questions in the forum also. That will be good. And some engineers also, they have some specific problem and discussion and all these things. Fine, that is also possible, but unless you clearly define the problem, diagram, oscillogram, and all these things, sometimes it requires, you essentially require for that particular application, a particular issues with protection and so. So in overall, thank you for this interesting questions and participation in this course. If you have any comment on improvement on this perspective, any suggestions which will be benefited to industrial perspective, from student perspective, from academician perspective, from faculty perspective, it is most welcome. Your suggestions are most welcome. Your questions are also most welcome. And anything missing in this today's presentation also, if you have that, please again inform us to this forum questions or any platform. We'll be we'll be happy to answer those questions. Thank you all. We'll meet again next time to address all the queries in the third session. Thank you.